In this video, we will discuss the following topics: the VisSim merge and cross-detect blocks, adding models to the VisSim menu bar, and creating a discrete integrator with reset capability. The VisSim merge block, located in the block's nonlinear menu, provides the if-then-else function. The block has 3 inputs and 1 output. The top input pin is the Boolean pin labeled B. When this is true, or 1, the output is set equal to the T input, which is pin number 2. When the Boolean is set to 0, or false, the output is set to the F input, or pin number 3. Let's simulate the merge block. From the block's signal producer menu, we'll select a button block and attach it to the Boolean input pin. From the same menu, we'll select 2 constant blocks and connect them to the T and F input pins. We'll set the true constant block to the string true input and the F constant block to 99.2. We'll attach a display to the merge output pin. Under System Properties, we'll set the end time to 50 seconds and check Run in real time. With the button set to on, we click Go to start the simulation. Dwelling on the B input, we see it is set to 1, and the display outputs the true value, which is the string true input. Clicking the button to off, the B input changes to 0, and the display outputs the false value, which is the value 99.2. The VisSim Crossdetect block, located in the block's nonlinear menu, produces a pulse when its input signal crosses through its crosspoint parameter. The Crossdetect outputs a +1 pulse when the input signal rises through the crosspoint and a -1 pulse when the signal falls through the crosspoint. Let's simulate the Crossdetect block. From the block's signal producer menu, we'll select a sinusoid block and attach it to the Crossdetect input pin. We'll set the sinusoid frequency to 1 radian per second and the Crossdetect crosspoint to 0. From the block's signal consumer menu, we'll select a plot block and connect the sinusoid to pin 1 and the Crossdetect output to pin 2. Under System Properties, we'll set the end time to 20 seconds. Next, we'll click Go to run the simulation. The sinusoid time history is shown in red and the Crossdetect output in blue. We can see that a +1 pulse is produced as the sinusoid rises through the crosspoint and a -1 pulse when it falls through the crosspoint. In certain situations, only the plus or minus pulse is needed. Suppose we only wanted to pass the plus pulse. Let's incorporate this change by adding a limit block from the block's nonlinear menu and connecting it to the Crossdetect output. After setting the lower bound to 0, we'll rerun the simulation. In the blue Crossdetect output time history, we see that only the +1 pulse is produced as the sinusoid rises through the crosspoint. It's convenient to add frequently used models to the VisSim embedded menu bar for easy access. Let's add a discrete integrator model to the menu bar under a drop-down named My Models with one subfolder named Integrators. First, using File Explorer, we'll navigate to the VisSim install folder. Normally this is C VisSim90. And we'll create a My Models folder and a subfolder named Integrators. Next, we'll open VisSim and load the discrete integrator model. Under Edit, Preferences, Menu Directories, double-click on the ellipsis. Browse to the My Models Integrators folder. Uncheck Open as New File and check Include.vsm files in subdirectories. Enter My Models for the menu header. Click Set, then OK. Save the discrete integrator model in the My Models Integrator folder. Close and relaunch VisSim for the change to take effect. Let's access our discrete integrator model from the VisSim menu bar. After launching VisSim, we navigate to the My Models drop-down, open the Integrator subfolder, and select the discrete integrator model. Let's modify the discrete integrator model to accept trigger and reset inputs, allowing the integrator to be reset dynamically. First, we'll open the discrete integrator model from the My Models Integrators menu. We'll rename the discrete integrator compound block to discrete integrator with reset. We'll add 2 additional inputs to the compound block. We'll name the input pins X, trigger, and reset value. Now we're done editing the top-level compound block, and we'll open the compound block to complete the editing. First, we'll attach variable blocks to each of the 3 inputs and name them with locally scoped variables, X, trigger, and reset value. We'll add a merge block upstream of the UD block and attach the trigger variable to the Boolean input, the reset value to the true input, and the summing junction output to the false input. We'll add the X input to the gain update time. We are now done editing the compound block contents. We will name this model Discrete Reset Integrator and save it in the My Models Integrator folder. After exiting and relaunching VisSim for the changes to take effect, we will test our reset integrator by integrating a unit step input. We will use a Crossdetect block to detect when the output value rises through 2.0. The Crossdetect pulse is applied to the trigger input of the reset integrator, causing it to reset to 0. We will need a step block, a constant block, a Crossdetect block, and a limit block. The Crossdetect crosspoint is set to 2.0 and connected to the output of the discrete integrator. Since we are only interested in detecting the crossdetect for a rising signal, the limit block lower limit bound is set to 0 and connected between the crossdetect block and the trigger pin on the discrete reset integrator. The step input is connected to the X pin on the integrator, and the constant 0 is connected to the reset value. A plot block is connected to the discrete reset integrator output pin. The simulation is set to run for 20 seconds with a time step of 0.001 seconds. Click and go to run the model. The integrated signal time history is displayed in the plot block. Each time the signal crosses 2.0, the crossdetect produces a trigger pulse and the integrator initial condition is reset to 0.